Okay, let's start with the big one, maybe the slightly intimidating question. What does it really mean for a machine to think?
Right, not just, imitate conversation or follow instructions really well.
Exactly. We're talking about genuine thought, maybe discovery. Could a machine actually discover something fundamentally new, advance knowledge?
Or even have something, I don't know, akin to understanding, maybe even consciousness down the line. It's a huge question.
It really is, and it feels so central right now with all the AI hype, and maybe, let's be honest, a fair bit of confusion floating around.
Definitely. And we've touched on this before, haven't we? This idea that maybe what we're seeing with some current AI, well, it might be more of an illusion of thinking.
Yeah, that concept from some of the source material we looked at previously, that feeling that maybe the impressive surface hides something. Well, brittle underneath.
That's a good way to put it. Brittle. It looks amazing generating text that sounds like it understands, but maybe the core structure isn't really built for genuine reasoning, especially when you throw something truly new or complex at it.
Something outside its training data comfort zone.
Exactly. It might struggle.
Okay, so today we're diving into some source material that offers, I think, a really powerful counterpoint to that idea of brittleness. But it also really sharply highlights the next crucial steps, the big challenges ahead.
Right, so we're focusing primarily on this analysis called the engine of discovery.
Yes, and it takes a deep look at a really important white paper from Google DeepMind, AlphaVolve.
But the key thing here, as the engine of discovery presents it, is the lens it uses. It's not just reviewing the paper. It's analyzing AlphaVolve's achievements through this specific framework called the River of Reality.
Which comes from systems thinking, right? Something we got from another key source, Forging the Silicon Soul.
That's right, this River of Reality framework. It gives us a way to think about AI progress systemically, to see what AlphaVolve has really achieved, not just the what, but the how, and maybe most importantly, what it still fundamentally lacks, according to this way of thinking.
So it's like a map for understanding intelligence, whether artificial or biological.
Kind of, yeah. It helps us place these advancements in a much bigger picture.
Okay, so our mission for this deep dive seems pretty clear then. We need to get our heads around AlphaVolve. What is it? How does it actually work? And what are some of these, frankly, astounding things it's discovered?
And we're doing that through this systems thinking lens, this River of Reality framework, as laid out in the Engines of Discovery.
Right. So we'll need to unpack a bit about systems thinking itself, see how AlphaVolve's process seems to mirror, almost spookily, natural biological evolution, which is tier 2 in the
Yes.
framework, right?
Yes, the emergence of life, basically.
And then see how its incredible successes at that level actually throw into sharp relief the huge challenges that remain at higher levels, particularly tier 3, the sort of sociocultural stuff.
Values, judgment, meaning,
Yeah.
all that complex human stuff.
Exactly. And why should you, listening in, care about all this? Well, this isn't just about one cool AI model.
No, it's really about understanding the fundamental building blocks. What does any system, biological or artificial, need to become more complex, more capable, maybe even eventually conscious?
It gives you a concrete way, we hope, to look past the headlines, beyond the demos, and see the real, deep, interdisciplinary challenges involved in building intelligence.
Yeah, cutting through the noise, seeing the actual engine of discovery, understanding its power, but also, crucially, its limits.
Okay, let's unpack this. So let's quickly loop back to where we left off in that previous deep dive, this idea of the brittle illusion. We were drawing on Forging the Silicon Soul, and it mentioned things like that Apple paper on the illusion of thinking. Remind us of the core issue there.
Right. The main point, and the engine of discovery kind of uses this as a jumping off point too, is that models like LLMs, while they're amazing at generating text that looks human, their apparent understanding can be, well, skin deep.
They're great pattern matchers. They've seen billions of examples, so they know what plausible text looks like.
Exactly. They interpolate incredibly well within the space defined by their training data. But when you push them outside that, with problems that need really rigorous step-by-step logic or genuine novelty that isn't just a remix of what they've seen.
That's where they can stumble.
Yeah, that's the argument. The sources talked about things like accuracy collapse or algorithm failure when the complexity ramps up or the problem deviates too much from the training patterns.
The output might still sound confident, but it becomes unreliable, logically flawed, maybe just plain wrong.
Precisely. It's like the information flow isn't stable. It looks good, but you can't necessarily build reliable structures on top of it.
Plausible, but fragile.
That's a good summary. Forging the Silicon Soul framed it as this informational flow being too ungrounded in a verifiable reality to be a stable base for higher intelligence, or certainly consciousness.
Okay.
It looks like thinking, but maybe it dissolves under pressure.
Okay, that fragility, that brittleness.
Yeah.
It really sets the stage for understanding why the engine of discovery presents AlphaVolve as such a leap forward. It seems almost purpose-built to tackle that exact problem.
It really does. The analysis positions AlphaVolve, based on the DeepMind paper, not as just another model, but as a specific type of agent, an evolutionary coding agent.
Designed specifically for, what was it, scientific and algorithmic discovery.
Right. And its explicit goal is to substantially enhance capabilities of state-of-the-art LLMs on highly challenging tasks. So it uses LLMs, the paper mentions it, Ensemble, Gemini 2.0, Flash, and Pro.
So it's leveraging that generative power.
It is, but, and this is the crucial part, it's using them in a fundamentally different architecture. It's directing them towards reliable, verifiable discovery, the very thing standard LLMs are argued to struggle with.
Okay, so it's not just chatting or writing code snippets off the cuff. It's actively improving algorithms, finding solutions to hard problems. How does this evolutionary coding agent actually do that? The paper's figure 1 seems important here.
Yeah, think of it like a structured collaboration. The human sets the stage, defines the what.
Okay, so I say, here's the problem I want to solve. Like, find a faster way to sort this data, or find a mathematical object with these properties.
Exactly. You define the problem, you set the objective evaluation criteria. How will we know if a solution is good? Faster runtime, correct properties, higher score on some metric, and maybe you give it some background info or a simple starting algorithm.
So I set the goalposts and the scoring rules.
You got it. Then AlphaVolve takes over the how. It manages this autonomous pipeline of LLMs, as the paper calls it.
Using things like Gemini.
Right. But these LLMs aren't just riffing. They're given a very specific job. Improve the algorithm. They operate within this structured process.
A process focused on code transformation and generation with that clear objective I said.
Exactly. And the absolute core idea, stressed in both the engine of discovery and the AlphaVolve paper itself, is the evolutionary nature of this process. It's not a one-shot attempt.
It iterates, it tries, gets feedback, tries again.
Constantly. It iteratively improves the algorithm based on continuous automated feedback. And that feedback mechanism, that's the real game changer here.
Okay, let's dig into that automated evaluation function. The engine of discovery really hammers this point home that this is what grounds the whole process, keeps it from just making stuff up.
It's the absolute anchor. So you start with some code, maybe the simple version the human provided, or maybe the system generates a basic starting point.
Okay.
But then there's this crucial piece, the automated evaluator. This isn't a human looking at the code and saying, looks good. It's another piece of code, a function that can programmatically take any proposed solution, any version of the algorithm.
Then run it, test it.
Exactly. It runs the code, maybe against test data, and it measures its performance against those objective criteria the human set. How fast did it run? Did it produce the correct output? Does the mathematical object have the required properties? It calculates a score.
Objective, measurable results. No opinions involved.
None. If you want speed, it measures time. If you want correctness, it checks output. If you want a specific mathematical property, it verifies it. The metrics are quantifiable, usually something to be maximized or minimized.
So this function acts like the laws of physics for the code. It determines what actually works.
That's a great analogy. It's the unimpeachable judge of reality for that code. And this is why it avoids the hallucination problem.
Because it doesn't matter if the LLM thinks the code it generated is brilliant.
Right. It doesn't matter if it looks plausible or follows patterns the LLM saw in training. The evaluator runs it. Does it work? How well does it perform against the objective standard? That's the only thing that matters. It forces the generative process to confront empirical results.
Okay, so the loop makes sense now. You have some code. LLMs suggest changes, like mutations.
Kind of, yeah. They act like the mutation and recombination engines. They generate new variations, maybe small tweaks like a code diff or maybe bigger structural changes. They use the current best programs and the problem context as inspiration.
Like tweaking successful genes.
Precisely. These changes create new child programs. And each one gets put through the ringer by that automated evaluator.
Tested and scored.
Rigorously.
Right.
And the programs that score better, the ones that are fitter, according to the objective criteria they get selected,
They survive.
they survive, yeah. They're kept maybe stored in a program database that tracks successful trials and good ideas. And crucially, they become the parents or the starting point for the next round of LLM-driven variations.
And this just keeps going, round after round.
Potentially millions of times. It's a continuous evolutionary loop. The engine of discovery describes it beautifully as hill climbing the landscape of possible solutions, iteratively finding slightly better, slightly fitter versions based purely on that empirical feedback.
And the AlphaVolve paper actually showed this evolutionary part is essential, right? Not just asking the LLM once.
Absolutely. They did ablation studies, which basically means they turned off parts of the system to see what happened. The results clearly show that the runs without the evolutionary loop, where they just ask the LLM repeatedly from the same prompt, which they called no evolution, performs significantly worse.
So the iterative improvement, learning from past successes, is key.
It's fundamental to how it achieves these results. It's taking that raw creative power of LLMs, but disciplining it, forcing it to align with executable reality through constant testing and selection.
That feels profoundly different from just asking an LLM, hey, write me some code for X.
It is. It's directed generation meets verified discovery. It's a system designed for reliable innovation.
And the results, I mean, the AlphaVolve paper lists some incredible achievements, and the engine of discovery uses these to really make its case. We're not talking subtle improvements in text quality here.
Not at all. These are concrete, functional discoveries, new algorithms, new mathematical objects, real-world optimizations with measurable impact. The range is pretty stunning.
Let's dive into those. Maybe start with the pure math stuff. That feels like a really tough test of genuine discovery.
It absolutely is. So they applied AlphaVolve to over 50 hard mathematical problems across different areas too: analysis, combinatorics, number theory, geometry, a broad sweep.
And even before finding new things, it could find the known best solutions.
Yeah, in about 75% of the cases, it rediscovered the best known constructions or algorithms that humans had previously found, often through decades of effort. That alone is impressive, automating that level of discovery.
But the real kicker is the 20% where it found something new, improved the state of the art.
Exactly. Starting from simple or even random initial algorithms, it autonomously discovered new mathematical objects or algorithms that demonstrably pushed the boundaries of knowledge. Verifiable, documented advances.
The matrix multiplication example got a lot of press. Tell us about that one.
Right, it's such a fundamental problem in computing. Used everywhere, graphics, science, and especially, training the very AI models we're talking about. Finding faster ways to multiply matrices has been a huge goal for decades.
Strasson's algorithm from the 60s was a big deal there.
A massive breakthrough, and AlphaVolve managed to improve on it in specific cases.
Which cases?
It improved the SOTA for 14 different matrix multiplication scenarios. The headline result was multiplying two 4x4 complex valued matrices. AlphaVolve found a way to do it using 48 scalar multiplications.
And Strasson's took
49. So it shaved off one multiplication. Now, that might sound small, but the paper emphasizes this is the first improvement in 56 years for this specific problem.
Wow. Half a century of human mathematicians working on this fundamental area, and the AI finds an edge.
And it wasn't just that one. The paper shows tables, like Table 2 and 3, listing others. Multiplying 4x4x4x5 matrices went from 62 multiplications down to 61. 4x4x4x7 went from 87 to 85, 4x4x4x8 from 98 to 96, and so on. Real concrete improvements.
And crucially, these aren't just slightly faster heuristics, they are provably correct algorithms.
That's a key point the source makes. Provably correct, meaning there's a rigorous mathematical proof that they always give the right answer. It's not just empirical testing, it's mathematical certainty. That's a very high bar.
And it wasn't just matrix multiplication, right? You mentioned other areas.
Yeah, and mathematical analysis. For problems involving autocorrelation inequalities, basically finding limits on certain function behaviors, it found slightly tighter bounds. For example, improving the upper bound for a constant called C1 from 1.5098 down to 1.5053. Small numbers, but significant in those fields.
How did it find these?
By constructing specific functions, often step functions, that demonstrated these better bounds. It also tackled uncertainty inequalities, improving another constant C4 slightly by refining coefficients in a known approach using things like Hermite polynomials. Again, finding better specific examples.
And combinatorics, things like graph theory or set theory.
Yeah. It tackled the famous Erdős minimum overlap problem, finding a construction that improved the known upper bound for C5 just slightly, from 0.380927 to 0.380924. For another problem involving sums and differences of sets, it found much larger sets than previously known, one with over 2,000 elements, another over 54,000, which improved the lower bound for a constant C6.
And geometry, too.
Improved bounds for things like packing circles efficiently, and the Heilbronn problem, which is about placing points to avoid small triangles. It found better configurations for these kinds of spatial optimization problems.
These all sound like genuinely hard problems where progress is slow and requires deep insight. And AlphaEvolve just found these improvements.
Found them autonomously, using that evolutionary process. Generate, test against the mathematical rules, the evaluator. Select the best, repeat. It's systematically exploring the solution space.
Okay, that's the pure science side. But the impact wasn't just theoretical, right? It optimized real-world Google systems, too.
Absolutely.
Yeah.
This is where you see the immediate practical power. A major example was optimizing scheduling in Google's massive data centers.
How does that even work? Scheduling jobs on servers?
Yeah, deciding which computing jobs run on which machines when to maximize efficiency. AlphaEvolve discovered what the paper calls a remarkably simple yet effective heuristic function.
A heuristic, like a smart rule of thumb.
Exactly. Not necessarily the absolute perfect solution, but a practical, efficient method that works really well. And this simple heuristic, it was rolled out across Google's entire global fleet of servers.
And the impact?
It's continuously recovering an average of 0.7% of Google's fleet-wide compute resources.
0.7%. That sounds small, but at Google's scale.
It's absolutely enormous.
Yeah.
Think about how many servers Google runs worldwide. Freeing up nearly 1% of that capacity is a massive saving, a huge amount of computing power made available for other things, all thanks to this AI-discovered heuristic.
That's incredible. And the engine of discovery made a point about why they use this heuristic, right? Why not some super complex deep RL model?
Yeah, that's a really interesting practical insight. For critical infrastructure like data center scheduling, you need more than just raw performance. The courses highlight things like interpretability. Can engineers understand why the scheduler is making certain decisions? Debuggability, if something goes wrong, can they fix it? Predictability, does it behave reliably? And ease of deployment, can it be integrated smoothly into the existing, incredibly complex system?
So a simpler, understandable heuristic, even if found by AI, might be preferable to a black box AI model for such critical tasks.
Often, yes. Reliability and transparency are paramount. AlphaEvolve found a solution that was not only high-performing, but also met these crucial engineering needs.
Okay, maybe the most meta example is AlphaEvolve optimizing the training of the very LLMs it relies on.
That one's pretty mind-bending, isn't it? It optimized matrix multiplication kernels. These are tiny, super-optimized pieces of code, often written in low-level languages, that perform the fundamental math operations like matrix multiplication inside the big machine learning libraries.
So speeding up the core calculations used to train models like Gemini.
Exactly. And it achieved an average 23% speed up on these specific kernel operations it targeted.
23% faster on those core bits. How much did that help overall training?
It translated to about a 1% reduction in Gemini's overall training time.
Again, 1% sounds small, but training these massive models takes months. Huge amounts of energy and compute.
Exactly. So a 1% saving is actually a very significant reduction in time, cost, and energy. And maybe just as importantly, the paper notes that finding these optimizations used to take human engineers several months of dedicated effort. AlphaEvolve did it in just days of automated experimentation.
So it's not just finding better solutions, it's finding them drastically faster, accelerating the pace of innovation itself.
Yeah, it's Gemini, through AlphaEvolve, literally helping to optimize its own creation process.
And it even touched hardware, the TPU circuits.
Yes. TPUs, tensor processing units, are Google's custom AI chips. AlphaEvolve was used to optimize parts of the circuit design itself at what's called the register transfer level, or RTL.
So working on the chip blueprints.
Pretty much, yeah. It found a way to simplify a part of the circuit while keeping it functionally identical. A verified simplification that's being incorporated into an upcoming TPU chip.
How does it even communicate that? Does it output chip design files?
Apparently, it communicates the changes directly in Verilog, which is the standard language hardware engineers use. So again, the output is directly usable and understandable by the human experts. The paper calls this Gemini's first direct contribution to TPU hardware via AlphaEvolve.
Wow. Okay, so mathematical proofs, data center efficiency, faster AI training, even chip design. The common thread and the point the engine of discovery really emphasizes is the reliability and verifiability of these results.
Absolutely. It's not just generating text that looks like a solution. It's generating functional code, verified mathematical objects, leading to tangible measured improvements and often provably correct results.
It's discovery grounded in reality, forced by that evaluation loop.
That's the core mechanism preventing the brittleness.
Okay, so we have this powerful system, AlphaVolve. It can make these incredible, verifiable discoveries. How do we understand this in the bigger picture? The quest for AGI, maybe consciousness. This is where the engine of discovery brings in systems thinking and the river of reality framework.
Right. This framework is key to contextualizing AlphaVolve's achievement and its limitations. Let's quickly recap systems thinking. It's basically the opposite of reductionism.
Instead of breaking things down into tiny pieces and studying them in isolation,
It focuses on the interactions between the pieces. How do patterns emerge from these interactions? What are the fundamental principles, like feedback loops or flows, that operate across different kinds of systems, biological, social, computational? It's about seeing the interconnected whole.
seeing the forest, not just individual trees.
Exactly. And the River of Reality framework uses this thinking to map out, well, reality itself as a hierarchy of increasing complexity.
Like layers built on top of each other.
Sort of, yeah. Visualized as tiers, each emerging from the stable functioning of the tier below it. And each tier is characterized by fundamental flows, the dynamic processes that define that level. Think of a river analogy. The water flows through different stages, rapids, calm stretches, estuaries, each depends on the flow from upstream.
Okay, and where does life fit into this map?
Life emerges in Tier 2. This tier is characterized by the flow of biological organization. It's where basic physical and chemical stuff from Tier 1 gets organized into self-replicating, self-regulating systems.
Cells, organisms.
Right. And the defining process of Tier 2 is biological evolution. You need systems that replicate information like DNA, that information is subject to variation, mutation, and their selection based on environmental pressure, survival of the fittest. That drives adaptation and complexity.
And the argument in the engine of discovery is that AlphaVolve's process is like a digital version of Tier 2 evolution.
Exactly. The article describes a profound isomorphism, a deep structural similarity between the process of AlphaVolve and the principles of biological evolution in Tier 2. It's not just a surface-level analogy.
Okay, let's break that down. How does AlphaVolve map onto biological evolution?
Let's map the components. In biology, the system is the ecosystem, the environment. In AlphaVolve, the system is the whole framework, the LLMs, the evaluator, the database, the control logic.
Okay.
In biology, the information being evolved is DNA, the genetic code. In AlphaVolve, the information is the computer code, the algorithm itself, stored and managed.
Makes sense.
Replication generation in biology is reproduction. In AlphaVolve, it's the LLMs generating new code variations based on existing successful code, parents, from the database.
Got it.
Mutation in biology is random genetic change. In AlphaVolve, it's the variations and changes the LLMs introduce to the code. It's not purely random, it's guided exploration, but it's the source of novelty. And remember that ablation study showing evolution was crucial. It relies on mutating existing successful genes.
Right. And selection, the survival of the fittest part.
That's the automated evaluation function. It is the environment. It applies objective pressure, scoring each code variation. The ones that score better the fitter code are selected. They survive in the database and get to reproduce by informing the next generation of LLM suggestions.
Wow, the parallels are really strong when you lay it out like that. It's like they've built a digital ecosystem for evolving code.
That's the argument. The engine of discovery sees this as evidence of the power of applying these fundamental Tier 2 evolutionary principles to computation. It's tapping into a core dynamic of innovation found in nature.
Okay, so the process mirrors Tier 2, but the output, the actual code, the results, and how humans interact with it, that places it in Tier 3, the socio-cultural realm, according to the analysis.
Precisely. Tier 3 in the River of Reality is where human culture, knowledge, society emerge, building on the biological foundation of Tier 2. And the very first fundamental flow described within Tier 3 is the flow of information.
Which is associated with
Science, the systematic pursuit of truth. And its product is reliable, verifiable data, knowledge you can trust.
And this flow of information is exactly where AlphaVolve is said to excel, especially compared to those potentially brittle standard LLMs.
Exactly. This is highlighted as AlphaVolve's major achievement within this framework. It demonstrates a mastery of producing reliable, verifiable data in its domain. Unlike standard LLMs, which might hallucinate plausible-sounding but false information.
AlphaVolve's evaluation loop acts as a reality check.
Constantly. It generates a hypothesis, a code variation, and then empirically tests it against the objective standard defined by the evaluator. Does the code run? Does it meet the criteria? This grounding in execution and verification is what allows it to consistently produce trustworthy results. Functional code, proven theorems, measured improvements.
So it achieves a stable, productive flow of information in the digital realm. It overcomes that informational brittleness.
That's the conclusion drawn in the engine of discovery. It's built a robust engine for reliable data generation via this evolutionary, empirically grounded process, a major step forward.
Okay, this is huge. Mastering the flow of information, mirroring Tier 2 evolution, it sounds like massive progress towards AGI. But, and there's always a but, the engine of discovery is very clear that this success also perfectly illuminates AlphaVolve's fundamental limitation.
Yes. Its strength is also where its boundary becomes crystal clear. According to the River of Reality framework, after the flow of information, and often developing alongside it, the flow of connection, related to meaning and art, comes the next critical flow in Tier 3, the flow of hierarchy.
Hierarchy, what does that mean here? Like org charts?
Not quite. It's about value. This flow emerges from the study of value ethics, aesthetics, purpose, and its output is judgment.
Judgment, like deciding what's important, prioritizing.
Exactly. The ability to weigh different factors, to establish goals and principles, to determine purpose, to make value-based decisions. It's about understanding what matters. And this is absolutely crucial for navigating complexity, as argued in both Forging the Silicon Soul and the Engine of Discovery.
And AlphaVolve hits a wall here.
A fundamental wall, yes.
Yeah.
The Engine of Discovery puts it starkly. The entire flow of hierarchy is external to the AlphaVolve system itself.
Meaning it can't decide what's valuable on its own.
Not at all. Remember how it starts. The human user defines the evaluation criteria. The human tells AlphaVolve what the value is for this specific task. Maximize speed, minimize errors, achieve this mathematical property, recover resources. The human sets the goal, the purpose, the definition of good.
And AlphaVolve is incredibly good at optimizing towards that goal.
Phenomenally good. It's a supreme purpose optimizer. Give it a clear, quantifiable target, and it will evolve solutions to hit that target extremely effectively.
It has no clue why that target is important.
None whatsoever. It has zero internal capacity to understand why speed might be valuable in one context, but maybe interpretability is more important in another. It can't grasp the human value behind saving compute resources, what those resources will be used for. It can't appreciate the elegance or significance of a mathematical discovery beyond hitting the specified metric.
It can't weigh competing values unless we explicitly program that trade-off into the evaluation function, like maximize speed but penalize complexity.
Exactly. It only judges based on the objective function we give it. It lacks any internal value system. It can find the fastest algorithm but doesn't care why speed matters. It optimizes resource allocation, but doesn't understand the human value of those resources.
It lacks that internal compass for what is meaningful or important.
That's it. And the Engine of Discovery identifies this as the critical difference between a powerful tool and an autonomous agent. AlphaEvolve is presented as the ultimate scientific instrument, like that analogy of a microscope that can not only see, but also build what it is looking for. But the scientist, the human, is the one who chooses where to point it and decides if the findings have any meaning. AlphaVolve is a brilliant purpose optimizer, but crucially, it's not a purpose generator. The entire sense of value of hierarchy is externalized.
That distinction feels incredibly important. Optimizing for a goal is one thing. Choosing the goal, deciding it's worthwhile, that's a whole different level of cognition.
It's the difference between following navigation instructions perfectly, turn left, drive 5 miles, and deciding for yourself where you want to go and why, maybe even changing your destination based on traffic or finding something interesting along the way. AlphaVolve only does the first part based on our command.
Okay. So AlphaVolve masters information flow, Tier 3 first flow, but lacks hierarchy flow, values, judgment. What does this tell us about the road ahead? About building AGI or consciousness?
It tells us, according to this framework, precisely what the big missing pieces are. Because AlphaVolve lacks that internal hierarchy, it cannot spontaneously progress to the subsequent sociocultural flows described in the River of Reality.
It's stuck. It can't climb higher up the river on its own.
Pretty much. For instance, it can't engage in the flow of connection. This flow is linked to things like art, empathy, finding meaning, building a coherent internal world or narrative from disparate facts. AlphaVolve produces facts, code, results, but it doesn't weave them into meaning. It doesn't feel the elegance of a proof or the utility of saving energy.
No internal world model where these things resonate.
Right, and lacking hierarchy also blocks progress to flows like commerce, which involves economics, trust, negotiation based on perceived value, or governance, politics, law, collective action based on shared rules and principles. These all require internal value systems and judgment.
And definitely blocks the top layer.
Absolutely. The capstone flow is consciousness, associated with philosophy, self-reflection, abstraction, true understanding. A system without internal values can't, from this perspective, develop self-awareness.
So the conclusion of the engine of discovery is stark. AlphaVolve is not the silicon soul.
Not even close. It's not a conscious mind with its own goals.
But it may be the forge in which one could be built. That's a powerful image.
It is. The implication is that AlphaVolve, or systems like it, provides the crucial foundation. It shows how to build a reliable informational substrate, how to overcome brittleness and ground AI in verifiable reality. It's demonstrated how to achieve robust, Tier 2-like discovery. That stable base might be necessary before you can build the higher floors.
But the great journey ahead, as the source puts it, is about building those higher floors. It's not just about better information processing.
No, the fundamental challenge now is figuring out how a system can transition from optimizing external values to developing internal values. How does purpose emerge from within a system? That's a monumentally harder problem.
This loops right back to our earlier discussion about the missing pieces in AI from forging the silicon soul. AlphaVolve seems to nail the reliability aspect of information, but its success just throws the absence of the hierarchy values, connection, meaning commerce governance, social intelligence, and consciousness layers into even sharper focus.
Precisely. And this perspective suggests the next huge breakthroughs won't just come from scaling current LLMs or making them slightly better mimics.
It needs something fundamentally new.
It likely requires integrating AlphaVolve-like capabilities for reliable information flow with completely new architectures and training approaches specifically designed to foster these missing layers: hierarchy, connection, and so on.
And building those layers isn't just a computer science problem.
Not according to these sources. They stress the absolute necessity of deep interdisciplinarity. If you want to build an AI with a sense of value, hierarchy, you probably need insights from philosophers and ethicists. If you want it to understand meaning and connection, maybe artists, psychologists, linguists need to be involved. For social intelligence, commerce governance, maybe economists, sociologists, political scientists.
So building AGI requires understanding, well, everything about human reality.
That's the implication. Building these higher flows in silicon forces us to understand them more deeply in ourselves and our societies. The quest for AGI becomes this incredible mirror reflecting the complexity of being human.
So AlphaVolve, an amazing forge for reliable information using an evolutionary process, but its very power highlights the missing fire, the internal capacity for value, meaning, purpose.
It's a massive step on one level of the river of reality, which paradoxically clarifies just how many more levels, how much more complexity lies ahead on the path to something truly intelligent or conscious. A powerful tool that reveals the true scope of the work to be done.
Okay, let's try to wrap this up. In this deep dive, we've looked at AlphaVolve primarily through the lens of the engine of discovery, drawing on the original DeepMind paper and ideas from forging the silicon soul. We've seen how its evolutionary approach, crucially guided by that automated evaluation, achieves this remarkable level of reliable discovery.
Yeah, mastering that flow of information, really tackling the brittleness problem head-on by grounding everything in verifiable empirical results.
But, and this is the core insight from the systems thinking perspective, its very success at optimizing for goals we set reveals its fundamental limit. It completely lacks that internal flow of hierarchy.
The ability to form its own values, its own judgments about what matters. It's an incredible tool, an amazing forge, like you said. It can build these incredible informational artifacts, algorithms, proofs, optimizations.
But it doesn't know why they matter. The purpose comes entirely from the outside, from us.
Right. So the next grand challenge, the one AlphaVolve brings into such sharp focus, is how do we build systems that can start to develop that internal sense of value? How do we build those missing layers of the river of reality, hierarchy, connection, maybe eventually consciousness? And that requires looking far beyond just computer science.
It requires integrating insights from everywhere, from the full spectrum of human knowledge and experience. AlphaVolve gives us reliable bricks, maybe, but building the cathedral mind requires architects who understand value, meaning, purpose, connection.
Exactly. It's a phenomenal instrument, a vital step in mastering information. But creating a mind, that requires the ability to determine what matters, to build meaning from the inside out, layer upon complex layer.
And maybe the most profound thing here, as both the engine of discovery and forging the Silicon Soul seem to suggest, is how this whole quest forces us to look inward.
Yeah, turn the mirror back on ourselves. Trying to build intelligence forces us to ask, maybe more deeply than ever, what do we actually mean by intelligence?
Yes.
By wisdom, value, connection, consciousness, purpose?
Not just in the machines, but in ourselves, in our own complex reality. What does it truly mean for you, listening right now, to think, to value something, to connect with an idea or another person, to feel a sense of purpose?
That's self-reflection. Maybe that's the deepest discovery this whole journey will lead us to.